All right, now I'm going to show you how to use MBIS and calculate atomic charges using the Psi4 quantum chemistry software package. So first, let's open up our input file, and here is an input file for HCl or hydrochloric acid. Now to run MBIS, there's 5 different options you can give it. The first of which is the MBIS max iter, which basically tells you how many iterations of MBIS to run before the code starts to complain and your calculation fails. And we have MBIS deconvergence, which basically sets how tight or loose you want the convergence criteria to be, um, as described in my last video. And running MBIS requires a grid, and, and for the grid, you can specify the number of radial points and the spherical points. If you want your answer to be more accurate, you can specify more radial points and more spherical points. And since we're using a grid, there's also an option called the pruning scheme, where you could choose the pruning scheme of the grid. And all of these options I have set to be the defaults. Now, to run MBIS, you can pick your favorite energy function. And this one I just went with a simple Hartree-Fock and CC PV double zeta basis set. Now, the important thing here is you want to return the wave function, and then you want to run OE prop on a wave function, MBIS charges, and give it MBIS charges. All right, and in this example, I've given you a singlet molecule, but if you wanted to run it on a doublet or a triplet molecule, make sure to specify reference UHF here. Otherwise, the calculation will fail. MBIS works with both RHF and UHF. So now let's run the calculation. You just simply write Psi4 and then your name of your input file. In this case, it'll be mbis hcl.in. You run it. All right, now the calculation is complete. So now you look for the out file, which should be mbis hcl.out. And now you have to scroll to the very bottom of the input file. And here it says computing MBIS charges. Now, one thing you may want to check when running MBIS is the electron count from the grid, which basically checks to make sure that the number of electrons um, that is derived from the integration grid is actually equal to the number of electrons in the atom. And as you can see here, the expected number of electrons in the hydrochloric acid molecule is 18, and the grid gave us 18, so we're good here. Now, for the MBIS charges, it is given right here, where according to the algorithm, it assigns 0.68 electrons to the hydrogen and 17.32 electrons to the chlorine. So it should give a charge of plus 0.32 to the hydrogen and minus 0.32 to the chlorine. And also, MBIS will give you dipoles, quadrupoles, and octopoles, and all that good stuff. All right. I hope this is helpful, and have a great day.